video will be on Canvas. All right. So these are the numbers that you need to practice. All right. The other ones are on there because we're also getting you ready for the SAT. But these are the ones for your test. All right. So make sure you practice these. All right. So for 1A, as Michaela said, all you would do is switch the X and Y values. All right. You could switch X and Y because you are given the X and Y values. All right. So it'd be -5, 6, 2, 3, 1, 9. All right. And that's it. All right. Let's take a look at B. What's our first step? All right. We rewrite with what? Y. Y is equal to 3x minus 6. All right. What should I write below that, Eric? You don't know the next step? Very good, Michelandi. Switch X and Y. All right. We switch our X and Y values if we have them, but then we need to switch our X and Y variables if we just have those. X is equal to 3y minus 6. And now what do we need to do? Very good. We got to solve for y.
Yeah.
Yeah. Add 6 on both sides. All right. So the main way that we find our inverses is we switch X and Y and we solve for y. All right. X plus 6 is equal to 3y. All right. And then what do we do now, Nyla? Divide by 3. Now I want you to divide each term by 3. Yes, earlier, this module was okay if you wrote x plus 6 over 3 and left that as your answer, but I want you to get in the habit of writing it as 2 terms because that's what will make it helpful when you graph. All right, the 3's cancel out here. Then you're left with x over 3, x over 3, plus what's 6 divided by 3, Elaine? Sorry, 2. Very good. Is equal to y. And what is the last thing I need to do, guys? Inverse function notation is x over 3 plus 2. All right? Very good. All right? Any questions? Yeah. Yeah, let me write you a pass. All right? Let's look at some other ones. All right? For C, what do you need to do? All right? First, we'll see you tomorrow. Y is equal to x minus 5 squared. All right? Then we switch x and y. X is equal to y minus 5 squared. Okay? Now, someone earlier today expanded. They said y minus 5 times y minus 5. And then they got y squared minus 10x plus 25. All right? But let's just get rid of the squared. Let's just get rid of it now. All right? So how do we get rid of squaring? Sorry. Yes, you answered it right. But I meant to ask, how do we get rid of a square? Oh, no, I said it right. You said square. Never mind. Good job. You locked in. I'm not. All right. Square root on both sides. All right? Very good. Square root of x is equal to, what would that be? All right? Very good. Just y minus 5. All right? Y minus 5 squared. If we take the square root of that, we get y minus 5. All right? Very good. Then what would we need to do on both sides? Add 5. All right? Go ahead and write your answer out and what you think it would be. Make sure you include inverse notation. All right? So you would add 5 on both sides. All right? Which of these is correct? What's in red? Just kidding, not in red. What's in blue or what's in green? 1 or 2? Number 1, all right? That 5 cannot just go underneath the radical, all right? Very good. So number 1 is correct, and our final answer would be F. And make sure you don't do what I just did. It's not F inverse. What is it? G inverse of x is equal to the square root of x plus 5. I think so. If that's g of x, I don't care what the inverse of f is. I don't even know what f is. It's like if I asked about who your cousin was and you told me who your friend's cousin was. Like, what? Cameron. All right, let's take a look at this one. Y is equal to 1/4 x plus 3. All right, now we better know, Eric, what's my next step after I change that? So I should write x is equal to 1/4 x, 1/4 y plus 3. All right, what would I then do on both sides? Subtract 3 first. Subtract 3. All right, here's a key point here. X minus 3 is equal to 1/4 y. All right.
When you're putting the square root, does it matter if I put it over x plus 5? Or just
Say that again.
for the square root, does it matter if I put it over x plus 5? Or just
The square root must be only over x. Yes, it does matter. Yeah, because this 5 that's being added is the constant 5. It's not the square root of 5. All right? Then, what do I multiply by? 4. Very good. We multiply by the denominator or the, what is that called? The reciprocal, 4 over 1. All right? Yes, what you multiply both on one side, you got to multiply on the other. All right? So what do I get on the left, Stephen? Very good. Notice, Stephen did a great job of distributing. Make sure you distribute. Is equal to, all right? Over fraction multiplied by a reciprocal is equal to 1. All right? So 1/4 y times 4 is just 1y, or y. That tells us h, inverse of x, all right, is equal to 4x minus 12. Very good. All right? Be perfectly clear about this one again. It's the square root of x plus 5. Not the square root of x plus 5 together. All right? Very good. Let's take a look at 2a. All right? 2a says to find the inverse. So again, rewrite it as y is equal to 2x minus 4. Then we have y changes with x, and x changes with y. Then we would add 4 on both sides. All right. Then we would have x plus 4 is equal to 2y. And divide both sides by 2. All right. Fabian. All right, so then what we need to do is we have to do x over 2 plus 4 divided by 2 is 2 is equal to y. So this tells you that inverse of f of x is equal to x over 2 plus 2. All right, now we have to graph that. What's my y-intercept here, Nevaeh? What ordered pair? 0, 2. What's my slope? Over 2, but what is the real slope? 1 over 2. Yeah, x cannot be a part of the slope. It's next to the slope. That 1 tells me to do what, Yasmin? Go up 1. Positive 2 tells me right 2. 0, 2. Up 1, right 2. Up 1, right 2. Go down 1, left 2 also. All right. We also want to graph this guy. Where do we start for that one? Braylon, 0, comma what? -4. 0, comma -4. All right. And then what is our slope for that one, Hannah? Hannah, what's our slope for f of x? 2 over 1. All right. Top number tells me what, Brendy? Up, because it's positive, guys. This one tells me right, because it's also positive. Very good. Up 2, right 1. All right. These should be going the same direction. All right. So if one's going up, you both should be going up. All right. Up 2, right 1. Up 2, right 1. And if you remember, where did I say they would cross? At a point where what is equal to what?
X equal to y.
X is equal to y, and y is equal to x, and they cross at 4, 4. Very good. All right. All right, so now we're going to jump around because some of them are a little bit more difficult, and some of them are kind of more important than the others. All right. So first, I want to take a look at number 14. Let's refresh our memory about what a composition is. All right? Sir, I need you up. Please. Okay? Can you go to number 14 and write this down? Okay? All right? And also, just pause a moment. Take a look at my 3 notations here. I'm doing something with 2 functions for each of them. Let's start here in the middle. What's going on between f of x and g of x? In blue, they are doing what? Dividing. What about in black? What is this called? Composition. This is a composition. This is multiply. Notice the difference. And this could also be the star symbol. All right, or an X. Okay? All right, all those mean multiply. But if it's an O or a circle, that means of for a composition. And this, of course, means addition. All right, and if the one I didn't write up was subtraction. Okay? All right, so now, how I would like you to rewrite this is m of n of x. All right, so that way you know whichever function is written first, like m, that's the function that you are rewriting. All right, so I'm going to write it over here again, m of n of x. All right, just to review how we get this. All right, where you're rewriting m of x, 5 times x minus 3. But notice, how did m of x change from here to here? X was replaced by what? This x was replaced by n of x. So this x needs to be removed. All right? So we're rewriting m, but instead of x, what should we substitute in? 2x. All right? So all we need to do is simplify this. Eric, what's 5 times 2x? 10x minus 3. Could that be simplified any further, guys? No, that's it. All right? Let's take a look at number 18a. This is all the directions we'll say. So you need to remember what it means to find the compositions of functions. All right? You need to go both ways. You have to show, you have to consider, is f of g of x equal to x? So that's what I'll do up here. And then once I get done with that, I'm going to do is g of f of x equal to x. Okay? So starting with the top one. Again, it starts with f. All right, so I'm just rewriting f. F starts with what variable? Sorry, what leading coefficient? -2. All right? Whenever you're doing a composition and you see an x, that's when you should stop and ask yourself, all right, I'm not writing x. I'm writing that function that's being inputted for the other one. So what is g of x? 1/2 x plus 3. And then at the end, don't forget subtracting 6. All right? -2 and +1/2, all right? Those are actually opposite reciprocals, which, by the way, are what your perpendicular lines, all right? That's the relationship they have with their slopes, opposite reciprocals, all right? So what's -2 times 1/2? -1. So this would be -x, all right? This is equal to -x. What's -2 times +3? -6 minus another 6. So altogether, what is this first composition equal to? -12. Very good. All right. So are these going to be inverses? No, but you still have to show the bottom one. All right. G of f of x, all right, is equal to, what do we start with this time? 1/2. 1/2 goes away. No, 1/2 does not go away. X goes away. What substitutes in? Negative 2x minus 6. All right. Then at the end, don't forget to add 3. All right, we distribute. Negative, or 1/2 times negative 2x is negative x. What is 1/2 of negative 6 give you? Negative 3, all right? You could remember that this negative sign comes down, all right? Where positive times a negative is a negative, and 1/2 times 6 over 1, same as 6 divided by 2, which is 3. All right, so that's why all of this gives us a minus 3. And then we have a plus 3 here. All right, and we have negative x. And is that it? That is it, because these cancel out. All right, now, am I done? Of course not. Usually when I ask that question, I'm not done. All right, but I guess I just said, is that it? And the answer was yes, actually. But what do I need to say now? Why aren't they inverses? Their compositions are not equal to x. Are not equal to x. All right. Now, someone asked earlier today, can I say that f of x and g of x are not inverses because they are equal to each other? Because they are not equal to each other? No, you cannot say that. All right. Because if I had negative x minus 12 down here and down here, they still would not be inverses. For them to be inverses, they both have to be equal to x. Very good. All right. We'll go back to 18b if we have time. But for now, let's take a look at number 7. All right. Please pay attention to number 7. What are they asking you to do with f and g, guys? Multiply f of x times g of x. So this is literally all of this mess. 4x to the third plus 2x squared minus 5x times 3x minus 2. All right? Now, I told you that you could distribute, but when I had a trinomial times a binomial here, I would use the box. All right? You either need to make 2 columns and 3 rows or 3 columns and 2 rows. All right? So on the top, I could have my trinomial, 4x to the third, 2x squared, minus 5x. All right, and then on the side here, 3x minus 2. Multiply your coefficients, add the exponents. 4 times 3 is 12. X to what power? X to the fourth. 2x squared times 3x would give us 6x to what power? To the third. 3x times negative 5x, x squared. All right. What would be in the bottom left? All right. Don't forget, when we go into the box, we are multiplying. All right. We'll combine our like terms at the end. Then we have negative 4x squared and 10x. All right. So rewriting your answer in standard form, what term should go first? 12x to the fourth. All right. After 4 comes 3. All right. Negative 8x to the third plus 6x to the third would be negative 2x to the third. All right. Then you have negative 15x squared minus 4x squared to get negative 19x squared plus 10x. All right. Very good. All right, once you have that one down, go ahead and try to do number 5 on your own. All right? Go ahead and try to do number 5 now on your own. Fabian, can you see if you can follow my directions? I'm going to put another problem on the board. I want you to just write it down. Can you do that for me? I'm going to stay right here. Go ahead and write down number 7 for me so you get something down today. All right? What are we doing? All right. So for number 5, guys, what does it tell you to do with them? Does it tell you to multiply? It tells you to add. All right. So don't be making a big box. All right. This first term. Sorry. This tells us, guys, h of x plus k of x. H of x is 6x to the third minus 2x squared plus 8x minus 5. We're adding, all right? And then we could just list this out. We don't have to worry about changing anything. 7x squared minus 3x minus 9. You could just look for the like terms. Straight up, just look, all right? I see only one 6x to the third, so I know it's that. Then I see a negative 2 and a positive 7 to give me a positive 5. X squared. 8x minus 3x is positive 5x. And negative 5 and negative 9 give me a negative 14. All right? Now, that's not the main way I usually showed it. All right? You can do it that way. I would say you write that first term, and then you write all of its like terms below it. All right? Sorry, your first polynomial, or your first function, I should say. So here's h of x. Let's line up k of x. All right, 7x squared. What does that go under? Where does the negative 3x go under? And what about the negative 9? Got to add. All right. Does 6 get added to anything? No. Or you could think there's a 6x to the third there. All right. Sorry, not 6x to the third. 0x to the third. All right. So we get 6x to the third, plus 5x squared minus 5x minus 14. All right. Are there any questions that you guys would like me to go over? Yeah. All right. Let's take a look at number 9 because that's what was asked. All right. Now this one won't be on your test tomorrow, but altogether there are how many marbles? 36 and 24 give me a total of 60 plus 11. And I don't want any red or blue, so that means I could have any yellow marbles. 11 over 71. BB. All right? Again, please make sure you watch the video that I created talking about these specific problems. 2AB, 5, 7, 14, 15, 18, and all of number 1. Now, I don't know if I got to number 15, but it is very similar to 14. All right? And then I'll also make sure I have the answer key. Test tomorrow.